Hello, it's recent students and teachers.
Hello, Mr. Wapa.
Thank you. Sit down. We will quickly go through what we have looked at in our last lesson. There is still on forces lesson number 2. We have found out that forces can be measured in newtons. So newtons is a unit that is used to measure force. And some of the instruments that we have looked at, we have found out that when we are trying to find or measure simple objects and find their forces, we use the instrument which is the spring balance or Newton balance. We found out that if we are using, trying to find force through using of masses or weight of certain thing, we try to convert if we are measuring in gram, we try to convert it to Newton. And we have found out that 100 grams will give us 1 Newton. So 100 grams is equivalent to 1 Newton. So that's the way we have to convert using that the equation, which is 100 grams equals 1 Newton. We will continue on looking at force lesson number 3. So that's our topic for today, force lesson number 3. Now let's just quickly go through what we are going to do in this lesson. We will design a model of seesaw. Right? Seesaw is one of the things that is loved by children. Children would like to be on a seesaw. They swing from one side to another. Right? So we will try to design a model of seesaw. We will make predictions of movement caused by forces. Right? So we will also use some objects which we'll use as force, and we will also try to predict their movements. And we will compare balanced and unbalanced forces. So these are the main things that we will do in this lesson. The materials that we will need for today, we will have some changes in the material list. We are going to use a pivot. We've used cardboard to make a pivot, plasticine, and other objects like this metal rings, or a stopper of a test tube. Or if you have coins, we can also use those. Right? 10 toya or 20 toya coins can also be used. So those are some of the materials that we will be using in today's lesson. Every activity we will have to go through step by step. So I will ask you, we will work together to carry out an activity and then follow it up with questions, finish it together, go on to another activity. So everyone should be working together, right, at a same pace. So you've got to work really hard and follow instructions very, very carefully. So let me have the runners from each group to come up. Have one of this and a ruler. This ruler. The objects you should have should be the same objects when you are trying to put them on the seesaw. Instruction. Design a model of a seesaw using, we don't have cues, but you use ruler and triangular or pivot there and make your own, or make your own using other objects of your choice. So first of all, the very first thing you do now is you set up the seesaw. Do not put anything on, but get the ruler, put it on the pivot, and try to balance it. Make sure it balances. Do not put anything on. The instruction is you just balance. The main activity we are trying to find out here is on forces. It may be related to weight, but you concentrate on looking at the content or the context of force. Now, if you have balanced it, I would now like you to do your predictions. Now, your recorders get the predictions down. The reporter is going to report straight after you make your predictions. Discuss and predict what is going to happen to the movements produced by the force. Now, force, we are going to use those objects you have. We are going to use them as force. Now, you make a prediction. What's going to happen to the forces that you will put on? Your prediction recorder, please write it down and then give it to the reporter. So the reporter will get ready to report to the class. Your predictions. Okay, which group is ready with your predictions? All right, we'll have Anna. Anna's group is ready, so who is the reporter in there, please?
When we put force or object, the ruler will measure how light or heavy the object is.
They're saying that it will depend on how light or heavy an object is. All right, good. Thank you. Receiving students, you should also, if you don't have these things, just by looking at the balance that they've set up, you can also do your predictions. Make your predictions. Tell your class what your prediction is. We'll have Carrot.
Okay, we think that the side that the right side or the left side, when we put the force on, it will go down. The ruler will go down. The side that we put the force on.
Okay. What if you put two objects, one on one side, another on another side? What's going to happen? What's your prediction on that? What's going to happen? Angeline, tell the class what's going to happen if you put two objects on each of the sides of the pivot.
It's gonna be balanced.
It's gonna be balanced, okay? She says it's gonna be balanced. Any other predictions? What do you think? Tanabik?
If they have the same weight, it will balance.
He's saying that if they have the same weight or the same amount of force, they will balance. Okay? Now, some of the predictions you gave are very good. I mean, many of the predictions. We will have to confirm whether your predictions can be true or not. Next step. You must get the objects you have must be the same size all right? And you put one object on each side of the pivot and balance the seesaw. Balance the seesaw by getting the two objects, put one on one side, another on the other side. Do not do this. Do not stick the ruler with the plasticine, right? You have to just make sure that it doesn't stick on you. Just try to put it. While doing it, answer the questions too. How can you balance the objects on the seesaw? And you explain why. You got coins there? You can use coins? No, you don't do this. Explain why. The first step you did was you balanced the ruler. Now, in the other step that you are doing, you don't have to move the ruler. You only move the objects there to balance. All right, let's see. Which group did not present on the prediction? We'll have those groups to tell us how they balanced the objects on the seesaw, and they'll explain to us why it was balanced. Jennifer, someone in your group to present to the class answering those questions. Question is, how can you balance the objects on the seesaw? So how did you balance it? Now the instruction was you were only asked to put 2, not 3, and then you use the objects, just move them to balance it. Is it balanced? Okay, balance it. Is there? Did you balance the ruler at the first place? Yes. Huh? Okay, try balance it first. All right, while they're still working on their balance seesaw, we'll have another group. Patrick, your group, the reporter there, tell the class, how did you balance the objects on the seesaw? And you explain why. All right, they're still working on the seesaw. Let's have other groups that have completed that activity. Okay, we will have Ovin to tell the class. Answer those questions quickly. We'll have Ovin. All right, Teresa will help.
Firstly, we marked the half of the ruler we put, we marked it on 50, and then we we marked 10 centimeters. We put our object on the other side, and on the other side we did the same, 10 centimeters. And when we put it, it was balanced.
Thank you. That's what this group did. Now listen, if you did not hear what they said, first of all, they got the center, the pivot, and the ruler 50 centimeter was put on the pivot. And then how they balanced it, they said that they tried to make readings that one side 10 centimeter, another side 10 centimeter. They put their objects, and that's how it balanced. So what did they use in here? The measurements. Generally, we can say they used from one point to another. The distance. All right, they've used distance in here. Good. Let's go on to the next step. Hope others have done the same. Now, put two objects on one side and one on the other side. What happens? So you should have three objects on the ruler now. Two on one side, one on the other side. When you do that, what happens? All right, tell your friends, what happens? What happened? Receiving students, you can also observe and maybe tell your friends what's happening here when they are putting two objects on one side and one on the other side. Recorder, quickly record down what has happened when you put two objects on one side and one on the other side. After you record your findings, next question, can you balance this? Two objects on one side, one object on another side. Can you balance it? You can move around the objects to balance it. Make sure those two objects are together. They are not separated, they are together. Together. Yeah, together. Yeah, together.
You then put it a bit down.
You try put this. Okay. Two, you put them together. Oh, put them together. See, like this one, see? Now, if you balance it, then you explain how you did it. Right? What's the explanation that you can give? Can you explain how did this thing happen? What's the reason? Knowing that there is only one object here, two objects here. Discuss with your friends why it has to be like this.
Balance point down.
Okay, you discuss among yourself.
Already.
You will find that there is one object on this side, two objects on this side.
It's not at the end where you put it down, it's in the center up where this one is.
So what you did is you move this one closer.
Yeah.
Closer to the what? The pivot.
Yes, pivot.
So when you're moving it closer, what happens?
The ruler is balanced.
Okay, what actually happens in here when you're moving it closer? Remember, we're talking about force. What happens in there when you're moving the object, the two objects closer to the pivot? What actually happens?
Of the what reduces?
It gets lighter.
Why?
Because this one is like,
It's the ruler.
no, wait, the force gets lighter when it's in the middle.
Middle,
because
yeah.
The pivot is,
Okay.
it's
When you put it down there, it can, that one
the
I
force
use.
is heavy. If
Yes,
you put it in the middle,
It's lighter.
the force is
Okay, why?
because
Why?
Because this
Talk about it. Why is it when you're moving it closer, you said that the force gets lesser? Why? And what conclusion can you come up with? All right, most of you have finished. You have already balanced. Recorders should already record your findings, what happened. Can you balance this? If you did, explain how you did this. We'll see which group is ready to tell the class their findings. All right, we'll have Violet and the group. They'll tell us what they did. When they put two objects on one side and one object on one side, what happened?
When we added two, the same weight, but when we had the other one, one side was heavy. So we tried to balance it by moving it closer to the pivot. And yeah, we think that if the closer the heavier side, the weight, is the closer it is to the pivot, the lighter it is. It will be more balanced.
Okay, that's what they found out. When they get the heavier distance closer to the pivot, they say that the weight or the force becomes less in there. Good. Any others? Thank you, Violet. Edward, what's your findings?
When we put the other one on the two objects on the other one on the right and on the other one on the left, it was like the other one was heavy, so it was going down. And when we move it closer to the pivot, it was like balanced.
Which one did you move closer to the pivot?
Both of them, the double, the object.
The object?
Yeah.
Okay, the object that has more weight. All right, good, thank you. So what you have really found out is that when you put two objects on one side and one on the other side, the seesaw was unbalanced. Any explanation to that? Why it was unbalanced? Receiving students, any explanation about that? Why is that the seesaw was unbalanced when two objects were put on one side and only one object on the other side? We'll have Bobby to tell us what he thinks?
Because the other object had more weight than the other one.
All right, when we're looking at it from the point of forces, what can you say? You're looking at weight now, but when we look at it on the point of view of what force is, what explanation can you give? Okay, let's have Rachel. Thank you, Bobby.
Yeah.
The ones that were doubled had more weight to push down the one that was on the other end, which was a single one. So we think that the ones that are doubled had more force than the other one.
Very good. That's what they think. Any others? All right, we'll have
Go.
Tanabik. Tanabik, tell the class.
Because there was more force pushing on one side than on
Yes.
the other.
Okay, so that's what they think. That is why they found out that the seesaw was unbalanced. Good. Now, tell us how you balance this. Did someone tell us already? Yes. Okay, that's done already. What we will do now is you will repeat by adding or removing those objects, or you can change the objects and just, I'll give you about 2 minutes to just try out other objects from other groups. You can change objects. Okay, good. Hope you have tried some others, and you can see how force works. I'd like you to quickly answer this question. Why is distance important in this activity? We're talking about distance from the object and the pivot. Why is it important in here? Receiving students, talk with your friends. The importance of the distance of the object from the pivot. How is it important, or why is it important? All right. Anna's group have already come up with the answer. We'll have Messi to tell us. Shane, get ready.
Because distance helps in balancing things.
All right, that's what that group thinks. Distance helps in balancing the seesaw.
Because the distance will determine whether the objects will
whether the object will go down or go up, or if the distance is correct, they will balance properly.
Okay. Thank you. That's okay. Distance of the object to the pivot. It will tell us whether the closer the distance to the pivot, what's going to happen? What sort of force will it produce? The distance, if it's further out from the pivot, what sort of force will it produce? If you put an object closer to the pivot, what sort of force will it produce? And further away. So you can see the difference. You can see the importance of distance of the object to the pivot. The importance of that. Now, if you have observed carefully, the closer you move the object to the pivot, the less the force becomes. Right? So that's the importance of the distance in this activity. We'll have only one person to tell us, the class, the differences between balanced and unbalanced forces. You have already found how the seesaw balanced and how the seesaw did not balance. So in terms of forces, how can you compare? What is your comparison of balanced and unbalanced forces? Receiving students, you have observed, if you have the materials and if you have already also tried this activity, try to differentiate, compare balanced and unbalanced forces. So what's the difference? Only one person will tell the class and we will finish off. We'll have Ayano. She will tell us the difference between balanced and unbalanced forces. Now it's talking about forces, balanced and unbalanced forces.
Balanced forces are where the forces are the same, and unbalanced forces are where the forces do not have the same, they don't balance.
Do not have the same
balance.
Force, huh? Okay.
Yeah.
All right, good. Now let's move on to our summary. Balanced force is when two objects acting from opposite directions are equal. Not one is greater than the other. So that's balanced force. Those two objects acting from opposite directions are equal. Unbalanced force is when two objects acting from opposite directions are not equal. All right, have a look at this. This will give us a clear understanding of our summary on balanced force and unbalanced force. A tug of war, you can see the cartoon there. There is the same force on one side. Same force on one side. When the forces are balanced, or forces are the same, there is no movement. All right. So one thing that you will have to know is there is no motion, no movement if the forces are balanced. So this is a balanced force. Look at this one. When the forces are unbalanced, there is motion, there will be movement. So you will see one side, there's not much force, and the other side. So this is an example of a unbalanced force. All right, our keyword for today is balanced force. Sorry, key phrase. Our next lesson topic is friction, lesson number 1. And the materials that we will bring are markers, papers, and worksheet. With that, you can put the materials together to be stored away. Thank you, receiving students, teachers, and the model class.